Once upon a time, in a world of curious minds, a young inventor named Alex wondered, how do bullets work? Alex spent hours in his workshop, surrounded by diagrams and disassembled objects, determined to understand. He knew a bullet wasn't just a metal tip, it was part of a complex system. First, there was the cartridge, a metal casing holding all the components together. Inside, at the very back, was the primer, a tiny cap filled with a sensitive, explosive mixture. Just in front of the primer was the propellant, usually gunpowder, which looked like small grains. And finally, at the very front, was the bullet itself, the projectile designed to leave the barrel. Alex imagined the moment a firing pin struck the primer with a sharp, swift impact. The primer ignited, creating a small, intense spark. This spark, though tiny, was powerful enough to ignite the main propellant, the gunpowder. The gunpowder didn't explode like a firecracker. It burned very rapidly. This rapid burning created a massive amount of hot, expanding gas. The gas had nowhere to go but forward, pushing against the base of the bullet. With immense force, the bullet was propelled down the barrel of the firearm. The barrel wasn't smooth. It had spiral grooves called rifling. These grooves made the bullet spin as it traveled, much like a quarterback throws a football. The spinning motion was crucial for accuracy, keeping the bullet stable in flight. Without rifling, the bullet would tumble erratically and miss its target. As the bullet exited the barrel, it flew through the air, maintaining its spin and trajectory. Alex realized that every part, from the primer to the rifling, played a vital role. It was a marvel of engineering, a chain reaction designed for a specific purpose. He sketched out the process, labeling each component and its function. His understanding deepened, not just of mechanics, but of the principles of force and motion. Alex shared his discoveries with his friends, explaining the journey of a bullet with enthusiasm. He emphasized that understanding how things work was the first step to understanding their impact. His friends were fascinated, listening intently to his detailed explanations. One friend, Maya, asked, "So, it's like a tiny, controlled explosion pushing something really fast?" Alex nodded. "Exactly, and the spin makes sure it goes where you want it to." He then explained the different types of bullets, each designed for specific purposes. There were hollow point bullets, designed to expand upon impact, and full metal jacket bullets, with a lead core covered by a harder metal. Each design had a reason, a specific effect it was meant to achieve. Alex also touched upon the safety aspects, the importance of responsible handling and storage. He explained that while the mechanics were fascinating, the power involved demanded respect. His workshop became a hub for curious minds, all eager to learn from him. Alex's journey of discovery taught him that knowledge was a powerful tool. It allowed him to demystify complex subjects and share his insights with others. He continued to explore, always asking how and why, pushing the boundaries of his understanding. His passion for invention and discovery grew stronger with each new project. Alex learned that every invention, no matter how small, had a story behind its creation. He felt a sense of accomplishment, knowing he had unraveled a mystery. His curiosity was boundless, leading him to explore other intricate mechanisms. He studied engines, clocks, and even the complex workings of a simple lock. Each new subject presented a fresh challenge and an opportunity to learn. Alex believed that understanding the world around us was a lifelong adventure. He encouraged his friends to ask questions, to never stop being curious. His story became an inspiration, showing that anyone could understand complex topics. All it took was a little patience, a lot of curiosity, and a willingness to explore. Alex often said, "The world is full of wonders, waiting to be understood." And so, Alex, the young inventor, continued his quest for knowledge. He knew that every answer led to new questions, and every discovery opened new doors. His journey was not just about understanding bullets, but about understanding the very nature of inquiry. He became a symbol of intellectual curiosity in his community. Children would visit his workshop, eager to see what he was dissecting or building next. Alex always welcomed them, patiently explaining his current project. He taught them that science was not just in textbooks, but all around them. From the smallest gear to the grandest machine, everything had a story of how it worked. Alex's legacy was not just his inventions, but the spark of curiosity he ignited in others. And so, the story of "How do bullets work?" became a tale of discovery, learning, and inspiration. A testament to the power of asking questions and seeking answers.